All right. So let's see. So Lee, you said that the last question we did was.
I think that was the graph. It was the white, the multiple choice questions.
Yeah.
Number 2, where select one
2.
answer choice.
It was number 2 with the
slope
minus the 2x.
This guy right here.
Mm-hmm. That was tough.
Gotcha. Okay. I'm pulling that up now.
So we finished
really
that
tough.
one.
GRE, ETS website.
And then so the next one is about average salary ranges.
Mm-hmm.
Okay.
Between type of employees.
Which are all of the choices are below livable wage. But
Okay. Gotcha. All right. So, anyone want to sort of take an initial stab at this one of what to do? First of all, how many people were able to get this one correct? I should say.
I took the easy route and I got it wrong.
I didn't get it correct, but I feel like I was on the path, but then I was like, I don't know.
Okay. So
I got it right, but
this was a tricky one even for me. This one was a little tricky, and it took a while to kind of understand what they were going for with this one.
I just did like the average. I didn't really try very hard.
I used the weighted mean to figure it out.
Okay.
Ooh.
I know.
What does a weighted mean?
From stats.
Oh, man.
It's kind of the way you you figure out your grade.
Mm-hmm. Okay. So, and were you able to get the right answer from that?
Mm-hmm.
Okay. Do you want to maybe take control and drive for a little bit?
We'll try. Let's see if I can write because I have the mouse pad thing.
That's the way you figure out your grades unless you have a certain
I'm going to make sure that this is recording the oh yeah, with the whiteboard I think it does record the whiteboard. There we go. Okay.
I'm not that great at explaining, so bear with me.
Do your best.
So I kind of separated it by the department X, which is 2 times, right? I put E. I don't know why I used E, which is equal to 225,000, right?
Okay.
Yeah.
Right, because in Department X
is twice the average salary for employees in Department X. Oh, it's twice as many employees. That's why I put 2E, because it has twice as many employees.
Okay.
And then I put DY, Department Y, is just employees, which equals their mean salary.
25.
Okay.
Right? So when we use the weighted mean, it would be 2 times the 2,500 plus the 35,000 divided by 3.
Uh-huh.
Which would then
and why 3?
Because of the weight of it, which is the 2 right here, the 2 plus the 1.
Oh.
Mm-hmm.
Right,
Okay.
which would then, I just did the math of this and it was 28,000, like that.
Mm-hmm.
So that was the highest possible. So then I chose A and B.
Right.
Mm-hmm. Right, because why A and B? Why not, C through G?
Because this is the highest possible that it could be. So it would be this and everything below that. I don't know, that was my thought process.
Okay. Yeah, that's great.
What you guys think?
Yeah, that's great.
Good job. Yeah, good job.
That's kind of what I, without knowing the proper terms, I was kind of thinking like, as the departments get larger, as there's more employees, that I guess now it's the weight of the 25,000 would be more because it's always going to be double the other one. So the value can only get closer to 25,000.
Yeah.
Right. This is, yeah, and that's exactly right. This is, because that's exactly the right way to think about it too. So because we know that in department X has at least twice as many, right? At least twice as many employees. So if we say 2 times 25,000, you know, that's the lowest bound, right? That's the low, or excuse me, that's the high bound for what this value can be, really, because it's for this average. Because the more people there are in department X, the lower the weighted average is going to be. So it can't be any higher than 28.3, right? So it can't be anything above 28.3. So does that make sense to everyone?
Yeah. That makes more sense.
Okay.
You want me to erase it?
That's okay. I can clear it. This is all recorded, so we don't have to worry about saving individual drawings anymore. It's all recorded. You can watch the video. But yeah, this is exactly how I did this problem. I had a different variable letter, but other than that, this is exactly what I did. So fantastic, great job. Okay. Now for the next question on this page, the function composition problem here, factoring. Who was able to answer this one correctly? Was anyone able to answer this one?
I think, well, because you were able to do, oh, this is the ones where you choose more than one answer. I got 2 out of 3, and then I didn't understand the third choice. I don't know if this is a formatting issue with the subscript, with the superscript.
Yeah, I think there's a little bit of an issue there where H minus G there, I think, on C. That's just, I think, formatting of the problem. It's not meant to be like a power or anything.
Okay, that was one part that threw me, but also just figuring that out couldn't get there. Okay,
yeah, and that's just because I tried to just copy these over from the web page into a PDF. Because on the web page it had the answers built into the web page, and I didn't want you guys to. I wanted to give you guys a version that didn't have the answers on it to work with. But yeah, so you said you got most of it right. Do you want to kind of show us what your thought process was?
Oh, me?
Yeah.
Talking to me? Oh.
And then I'll take over where you've got trouble.
Sure. Okay. If F, G, and H are positive integers such that F is a factor of G and G is a factor of H, which of the following statements must be true and indicate all such statements? Okay.
Okay. So and can you describe what does it mean that something is a factor of something else?
So that means it's like a multiple. Like I can divide by that number and get another integer. Okay. Like it's not going to end up with a decimal, right? Okay, right. So, for example, 2 and 3 are factors of 6. Right. Right. Yeah. And by that account, 2, 3, and 6 are all factors of 12 because you can pull those values out of 12, right? They all can be multiplied with something to make 12. Yeah. Okay, so could you get can you guys see as I'm typing, or does it have to? I have to like finish. Like I think once you finish, it all pops up all together. Okay. Okay, so this is what I kind of figured out. Like, F is a factor of G, so F divided by G, like F over G. F is a factor of G, so that gives you another integer. So if it was like 2 over 6, that would give you 3. So it's not going to be a fraction, right? And G is a factor of H. So that gives you another integer.
Let's see. Do you
Not
mean that the other
necessarily.
way around? That G divided by F is another integer?
I
Because
think
saying
I do
F,
mean that the other way around.
Yeah,
Yeah. So 3 over, yeah. Right. That's, sorry. I don't know how to fix that.
if you use the select tool from the toolbar,
The
you can
mouse?
double click onto something, and then it'll allow you to edit it. Yeah, I think you mean it the other way for both of those things.
Yeah, that's what I meant. Sorry. Annotate. I'll just. Oop, I erased all of it. But okay, whatever.
Control G and you can bring them back. But yeah, if you just use the select tool and double click on a text box, you can edit the text box.
I don't see a select tool.
Let me do it. Let me take over for just a moment.
Okay, sorry.
Yeah. So pretty sure you meant
G. Yeah, G over F. Right.
this and this, right?
Yeah.
Okay.
Right. Sorry, I did this like it was quite a while ago now. So so if like the other integer, let's say, could be, you know, anything. I'll call it X. You know, so X F equals G, and Y G equals H. So like, I'm just gonna call here, I'll just plug it in here. So like another integer X, another integer Y. I'm just kind of reversing that equation, like H over G is Y something else, depending on, you know, it's just knowing that X, now I'm stating that X and Y are both integers. So F is a factor of G. So then you're just gonna go through, so I have all this information, and I'm looking at option A. So F is a factor of G squared. So so G squared is divisible by G equals G, and G is also divisible by F, as we already know. So that means that I can if I can put F into sorry, I'm like mixing myself. So if I can put F into G, can you guys see my mouse too, or no? Can you see this? What I'm pointing at? Okay. Yeah, so if I can put F into G however many times, well, G squared is multiplied by itself. So which means that if G squared is G times G. So if F is a factor of G, F is also a factor of the second G, which means that F must be a factor of G squared. Does that make sense?
Okay. Are you able to write that out?
Yeah, so it's kind of like
you've got the right logic. Can you actually write it explicitly?
So G times G equals G. I don't know how to do a subscript, so squared.
If you
or just draw it.
If you want to do the little caret symbol, you know, the shift 6, I think that's generally like in you know, in like programming languages that usually works as like a squared symbol.
Got it. Like that.
There you go.
Okay. So basically, okay, so this first one, I know I'm kind of getting a roundabout. Now I think I'm back on track with explaining. So G is made up of X, which is some other integer. It doesn't really matter what it is. And F. So if I can, so if G times G is G squared, I can rephrase this as XF times XF also equals G squared,
Okay.
right?
Mhm.
So therefore, F is a factor of G squared.
Yeah, because you could pull the F's out and there it is, right?
Right.
Okay, great.
Everyone with me so far?
No.
No? Let me see. I don't know if I'm explaining it very well. So, okay, so we know that, let me, you know, on this, forget about the Y, G, H part, but, okay, F is a factor of G. Let's just, if we focus on just that part, F is a factor of G, which means F times something, another number, is going to equal G. So that's, we have this XF equals G.
Right. We have the G equals F times something. Right.
Right. G equals F times something, because we know that whatever that something is, if it's, you know, 2 times 3 equals 6, whatever, they're all whole numbers. So basically, and let me draw a box around this one. So this is what's important. X, I know that F is a factor of G, and whatever that other thing, I'm going to add another variable, which maybe is making things more complicated, but I know that whatever that other variable is, which I'm calling X, times F is going to equal G, because I can divide G by F.
F is one of, you can create G by multiplying F by something.
Right, by something.
We don't know
So
what that something is, because we don't know what the actual values of any of these things are. We just know this.
Yeah.
We know that
So,
F is a factor of G, so it's, you can multiply F by something to make G.
yeah. And then, so in order to make G squared, I just times G by itself.
Mm-hmm.
And then I can basically substitute in this equation for G.
Right.
And I know that I can see that F is still in there as a factor, because it's very, it's still going to create whole numbers.
Mm-hmm.
Okay. So now I also know, so B, F is a factor of G, H. So G is, G is a factor of H. So this is our other, maybe I'll change colors. This is our second equation. It's the ugliest circle. So H, did I say this backwards? G is a factor of H. Right, so H divided by G is another integer. So I'm just going to call that Y. Mm-hmm. So I know that Y times G is H. And so F is a factor of G, right? So I can basically pull this out, and what I want to have is, if F is a factor of G, what I basically am like left with is I can substitute G again for X F. And that equals H. So now I know that I could also say that F is a factor of H, because it's basically, I'm just breaking G into its parts. So I have Y times X times F is gonna equal H. So even if so then it says F is a factor of GH. So just by adding another G, this is Y times G equals H. So if I want to do GH, y times, I've already substituted g once. And then if I want to multiply it again, I feel like I lost my train of thought, but if you guys understand where I'm going. Yeah.
Well,
So-
I'm a little lost. Are you trying to write out GH right now?
Are you
I'm not-
trying to do it?
No, because I'm trying to, like, I don't need to make another equation. I'm trying, like, I feel like I'm explaining more than what I actually like figured out. So I'm like having trouble like verbalizing it. And let me change the color. This also. So YG equals H Y so GH, oh, so YG, Y times G times another G equals GH. That's where I was going. Okay, sorry. Does that make sense?
Are those multiplication signs?
Yes, those are.
Instead of using X, since we're using X as a variable, why
Oh,
don't you use
you're right.
like asterisk to make it more clear
You
what
are
you're
totally,
doing?
yes, you are very right about that.
Because we've used
Why?
X like 3 times
You're right.
in
I
this
know.
on this page, and it's half the time it's for multiplication, half the time it's for
You
a
are
variable.
correct. That's maybe why I'm getting myself confused as well. Y times G times G equals G times H.
There we go. That's a little bit more clear.
Yeah. So basically I could just substitute again that first thing. Like I could just put for all the G's, I could put XFs in there. And so I know F is part of this equation. So I could just do G at the end here. Sorry, I feel like I'm sounding like a maniac. This final thing, I could just substitute for G again and put XF, and then it's X times F times H. And so I know F is a factor of G times H.
The answer
Like-
would be B.
So A and B are both true. Now, I did not understand how to figure out whether C is apparently true as well, right?
Yes.
I did not know how to get to that point, though.
Okay.
Obviously, I way over-explained.
Okay. Let
all
me
of
just ask
this,
real quick. Is everyone following so far with the explanations for A and B, or is it still a little iffy?
Yeah,
here?
please explain it differently, because I didn't really like have
Okay.
to draw all
I
this
get
out.
it
Yeah.
a little bit. Well, I get it, but I mean,
I feel like everyone's still a little iffy on this, so I think I might kind of take over here and see if I
Yeah,
can
please do.
clear it up a little bit. All right.
good job, Nick.
You did
Yeah,
really good
great job.
I
I
was
think
getting it.
you're definitely on the right track. You've got most of it, but let me see if
Yeah.
I can help. Let me see if I can help kind of pull it together here.
He erases everything.
Just to, I'm gonna help explain those last two a little bit. Okay, so all right, so Leah's right here. So the idea is, so something is a factor of something else if you can multiply it to make the other thing. So like, so if we're talking about like the number 6, what are things you can multiply to make 6?
3 and 2.
2, 3.
3 times 2, and
Times 1.
yeah, 6 times 1. So these things are all factors of 6. You can multiply 3 times 2 to make 6. You can multiply 6 times 1 to make 6. I think that's about it, right? So those 3, 2, 6, and 1 are the factors, possible factors of 6. Let's think about 12. What can you multiply to make 12?
6 times 2, 3 times 4.
Yep, 6 and 2. You can do 4 times 3. Obviously 12 times 1, right? And I think that's about it. So 6 is a factor of 12, 2 is a factor of 12, 4 is a factor of 12, 3 is a factor of 12, 12 is a factor of 12, that's itself, and 1 is a factor of 12. So to say, you know, that you know, f is a factor of g, that just means that f times something equals g. And to say that g is a factor of x, that means g times a different something, possibly the same something, who knows, something is equal to h. So that's what it's saying when it's talking about factors. So I'm going to do basically the same thing that Lee was saying here. So if we have, so it's saying, is it true that f is a factor of g squared? So if we have g squared, what is that equal to? If we're looking at f equals fx, it's like, well, that equals to g times g, right? Which we know what g is. So what's g if I break it down?
It's going to be f of x, f times x,
F times x?
f times x. I hear
Right.
myself.
Right. So there we go. Which, yeah, that's it. Which is f squared x squared, right? Pretty sure. Which you can pull f out of that to f times something, right? Fx squared. But yeah, that's really as far as you need to go, because you can see it's f times something. So now we see, okay, g, you know, simplified, g squared does equal f times something. We don't care what. But we were able to figure that out. Does that make sense, guys?
Yes.
Okay, great. We're going to do the same thing with GH. So GH. So we're going to do the same thing. That's, you know, G times H. What's G?
fx.
There we go. And what did we say H was? It's G is a we could break it down to G times Y, right? G times some other thing.
Okay.
And it's like, well, okay, we could simplify this even further, but we've essentially just said, okay, well, this is f, x, g, y, which, there we go, it's f times something, right? Which is just f times something. So gh is equal to f times something. And that's all we're trying to find with this, is f is a factor of gh. And yeah, it turns out it is. Everyone following so far?
Yes.
Okay, great. The last one. This is the one that Lee was having trouble with. So let's go and do it. So h minus g. Okay.
Bye.
Okay. So here we go. So what's h? It's gy, right? Minus g, and we said g is fx. It's like, oh no, there's a minus sign in here now. What this is throwing us off, because we can't just pull that f factor out, right? Because there's a minus. We can only pull it out if everything is multiplied together. Well, let's break it down a little bit further. So we have g here. What did we say g was? G is f of x, right? Or excuse me, f times x. So over here we've got f x y minus f x. Well, when you have common terms,
You can cancel them out?
it's not that you can cancel them out. That's when you have them common terms on a division or on like a opposite on top and bottom of a fraction. But when you have them in something like this, when you're adding them together, you can pull the common terms out if you want. So I can just pull the f out. And this is f times xy minus x. I could pull the x out if I want to, but this is really what I'm looking for, is f times something.
Mm.
And there we have it. H minus g equals f times something. And so there we go. All three are true. So does everyone see how that all worked out?
Yes.
I just saw Patsy just go.
Yeah.
Okay. Any questions with how that all worked? Okay, so you guys are totally cool with that.
Yeah.
If you get another composition question like this, you're going to be aces.
I'm going to rewatch it over and over again.
Yeah. Yeah, I'll
Okay.
reference back.
You could just skip my part.
No, you were pretty close. You just like you had the logic in your mind. You just weren't sure how
Yeah.
to pull it out.
Yeah.
Right.
Okay, that's great though. Great job, everyone. But yeah, so with that one, all three are correct. A, B, and C are all true. Okay. So let's look at the next one. The next one is tricky for different reasons. So here we go. If x equals 10 to the negative 1 power, what is the value of x plus 1 over x times 1 over x? Okay. Who was able to get this one?
I got it, but it was like complicated fractions.
Okay. Do you feel, since you're saying it was complicated, do you feel comfortable trying to explain it, or do you want me to kind of go through it instead?
To go through it. You
Okay.
explain better.
Okay, all right. So there's a trick here, obviously. And the trick is knowing what a negative power means. So when you have, x plus x, let's just do a quick little review. X plus x, what is this equal to?
2x.
X squared or 2x?
Right,
I don't know.
2x.
2x, I don't know.
X plus x plus x, it's just, you're essentially adding that many x's together, right? When you have x times x,
You have x squared.
right? Adelaide's in the back of saying here, that's x squared. That's correct. So x times x times x equals x to, that many x's multiplied together, right? But now we've got this monkey wrench of x to a negative power. What is a negative power? I see some crinkled grimaces on people's faces.
I just know that it's like the reciprocal. I know that
Okay.
you like x, that would be like 1 over 10
Okay.
to make it positive.
You're on the right track here. It's like it means 1 divided by
Mhm.
that. It's the inverse.
Yes.
In the same way that multiplication and division are inverses, addition and subtraction are inverses. Positive and negative exponents are inverses. So x to the 1 equals x, or x over 1. x to the minus 1 is 1 over x. X to the minus 2 is 1 over x squared. You know, and so on. So in other words, x squared times x minus to the minus 2 should cancel each other out and make 1. So knowing that, x equals 10 to the minus 1, what does that actually equal to if we simplify that?
1 over 10.
All right, yeah, Adelaide said back here, 1 over 10. It's, you know, you can think of it as 1 over 10 to the positive first power, which is equal to 1 over 10. So knowing that, let's try and simplify the equation that they gave us. So x plus 1 over x times 1 over x. So we could distribute if we wanted to first, right? Or we could, you know, swap in 1 over 10 for x and just try and rush through it. Let's just try and go straight for it. How about? So x is going to be what?
1 over 10.
1 over 10.
All right. Plus
10 over 1.
exactly. I didn't even need to go an extra step. Adelaide already knew that when you have a fraction, 1 over 10, you can rewrite that as 10 over 1. So great job, Adelaide, for remembering that. When you have a over b, I had to write this down on every math note card that I was allowed to make, is equal to a d of how that all worked. The denominators flip the positions they're in for both of those. So yeah. So 1 over 10 plus 10.
Sign language.
Plus 1 over x again, 10. Okay. So this becomes pretty easy now, right? I'm going to distribute the 10 to both of them. So 10 times 1 over 10. So that's
Is 1?
Yep, 10 over 10, which, you know,
It's 1.
that's going to be 1. Plus 10 times 10.
100.
Yep. And so your answer is
1.
this problem looks really tricky because of that it's got fractions, it's got negative exponents, it's got variables. Oh my God, this thing looks complicated. But as long as you know the tricks, this one turns out to be, you know, one you can solve in just a couple of pencil strokes. But yeah, it's just tricky looking and just meant to confuse you and scare you, and that's all. So
Word.
does this make sense to everybody?
Yeah.
All right, great. Okay.
Everything's hard unless you know the tricks.
Okay. The next one is everyone's favorite topic, probability. Before we start that one, I'm gonna check with Adelaide on something. How are you doing temperature-wise? Getting a little warm? You want me to turn the AC on?
No, I'm fine.
You sure?
I'm gonna use the restroom.
Alrighty.
Get water.
I won't take my headphones with me.
Don't worry, we won't hear anything.
I know.
At least as long as he doesn't take the camera.
Do you want me to use some ice water?
No, it's fine. Thank you.
Okay. So I'm going to go ahead and clear the board. All right. So probabilities. Would anyone like to volunteer
Oh,
to read the
no.
question?
I'll read it.
Okay, go Patsy.
Wait, should we wait for Lee or?
Did Lee just get up to take a quick
Yeah,
break?
he
Went to the restroom.
Okay, we'll wait for him to come back. Adley, would you like to grab me something cold, like a soda or something? It sounds like we have a few seconds.
He needs an ice cream.
Just
I'll be right
ice
back.
With new water, maybe.
Ice and water. Ice water. Okay, I will be right back.
That one tastes a little bit weird.
Okay, no worries. I'm gonna mute my mic if you want to. There we go.
Oh, okay.
Yeah, so you could chat with us.
Girl time.
Okay, ice water. I'll be right back.
Before he comes back into the
I
room.
know.
I see him with shorts. I never see him with shorts.
Those are probably his boxers.
Oh, so nuts.
I had to like pull everything up in the back of my closet for summer because everything was like in the back. Like, oh, I'm not gonna use it right now, so I had to transfer everything.
I'll do the whole change of wardrobe.
Yeah, it was hot this morning. I was like, yeah, I'm not wearing pants.
Did you? So that email that I sent you guys is like that's gonna be it for from now on
Okay.
for this thing. Okay.
I'm gonna save it. So it's gonna be recurring.
Yeah. So Lee already knew that was it, and I had opened it, and I forgot about it. So I was chatting with Scotty about one of the about this problem actually. So I think we were just chatting about it, and all of a sudden, all of a sudden I just hear a voice. Hey, and I was like,
That's creepy.
Oh, is it when
Lee.
I came in?
You were stalking them.
yeah.
I figured because I saw the 123, so I was like, this has been the same password for the last couple of times. So I figured it was the same one.
Yeah.
Start memorizing it.
Yeah, and I just updated my calendar appointment.
Your calendar appointment?
Yeah, so
Yeah,
calendar you in.
I have you on the calendar and with a note of the
of the
Zoom
Zoom meeting?
Yeah.
Nice.
That's good. Fancy.
I haven't done that, but
I just get it through email and I'm like, okay, it's time.
Yeah.
Me too.
I mean, especially like especially now with like every day seeming like the same.
Yeah,
but I
it's
always needed like as soon as I started school, what stuff on my calendar is like crucial because otherwise I'm like, what's due? What day is it?
Yeah.
what day is it?
do?
I know.
I had to buy one and literally place it right in front of me, like it's on my wall on my desk because, yeah, me too. I couldn't keep up anymore. It was too overwhelming.
Yeah, because before school, it didn't matter. So if it was Monday through Friday, that's all that mattered. And then there was the weekends. It was. I mean, actually, that's not true because I spent most of my life working weekends and and having Tuesdays and Wednesdays off or something like that. So
You felt really out of it, really random.
How did you do that, Lee? Like, I don't. That's a hard, difficult, like life.
You get used to it. Retail, that's how it is.
You get used to it, and I mean, I did. Yeah, I was also in my 20s. Well, actually, it's not true. It was I only left the regular restaurant industry like 3 years ago. So, but
it's a lot. Just go with it.
I don't know. Yeah, you get used to it.
Yeah, I remember when I was in my early 20s, I had like 3 jobs and they were all in the same place. So I would really go from one to another, just change outfits and go. It's crazy.
Okay, good.
Yes.
Okay.
I will leave.
Want to swap mics?
Sure.
Okay. Everyone ready for fun probability time?
Woo!
Yeah,
Okay.
I attempted this and did not get far enough. I was like, okay, I'm not getting it.
Okay, no worries. Patsy, go ahead and read the problem, and then I'll go and give us a little probability recap.
A little secret? Okay. So a university admitted 100 students who transferred from the other institutions. Of these students, 34 transferred from two-year community colleges, 25 transferred from private four-year institutions, and the rest transferred from public four-year institutions. If two different students are to be selected at random from the 100 students, what is the probability that both students selected will be the students who transferred from the two-year community colleges? Whew. And then give your answer as a fraction.
Okay, great. And most of the time when you're dealing with probabilities, your answers are going to be fractional. That's because usually you're dealing with something, you know, how often does something happen? And it's like, oh, well, it happens, you know, 10% of the time, or 1 out of every 10 times. So first of all, was anyone able to get the right answer for this? Okay.
No.
All right. So I think before we actually solve the problem, I'm going to give you guys a quick little recap on basic probability. And I don't think on the GRE you'll get anything more difficult than a basic probability question. First of all, you all took statistics, right? Okay, so you probably had like at least like a week or two, like a real introductory look at probability, right?
Yes, and it was torture.
I can understand that. Our brains are not really built to understand how probability works, which is why Vegas makes so much money, because people do not our brains are not wired to understand probability. I'm serious. You know, it's the idea that, oh, well, the slot machine hasn't hit all day, it's going to hit soon. I need to keep pumping more money into it. No, that's not what, that's not how it works.
That's my logic.
Yeah, it's like when, you know.
That's how I lost my money.
Yeah, you need to slap it away. Okay. But yeah, this, I'll give you a quick rundown into how probability works. So let's start with a really simple example. Suppose I have a hat. This is my hat here. Actually, let me make this a much bigger hat. Okay, and I have, let's say I have 10 colored balls in this hat. It's a really big hat. Okay, so I've got 1, 2, 3, 4, 5, 6 red balls, and 1, 2, 3 blue balls. No jokes here, please. And 1 green ball. Okay. So how many balls do I have in this hat?
10.
Okay, great. So number of balls equals 10. How many are red?
6.
Okay. How many are blue?
3.
3.
Okay. How many are green?
1.
Okay. Great. Okay. So that's the first step to solving any sort of probability problem, is figuring out what all of the numbers are. What's the total? What are the what's the makeup of that total? What is the probability of doing something? It's the number of times that outcome is possible out of the total number of outcomes. So what is the probability that if I reach into this hat and grab 1 ball at random, what is the probability it will be a red ball?
Would it be 6?
6 out of 10.
6 out of 10.
Right? Yeah.
Okay, right. So it's the number of possibilities. Excuse me, it's the number of the outcomes I want over the total number of outcomes. Right. So 6 out of 10 to get to pull a red ball. What's the probability? So that's probability of red. What's the probability of blue?
3 out of
3 out of 10.
Okay, great. I'll just say, prob of blue. And then what about green?
1 out of 10. 1 out of 10.
Great. Okay. Adelaide said 1 out of 10. That's fantastic. You guys are doing great. Okay. Now I'm gonna change things up a little bit. This is assuming that I always, assuming that I put the balls back in the hat after I draw them, right? What happens if I don't take the balls back out of the hat? This 10 number is now no longer accurate, right?
Correct.
That changes all the probabilities. So what's the probability? Let's say I pull one ball out of the hat and it's red. And I take that ball and I, throw it away. So now there's 9 balls left in the hat, right?
Yes.
And so you take 1 red, throw away. What are the probabilities now? First of all, how many red are there now?
5.
5.
5. How many blue?
3.
3.
And how many
3.
green?
1.
Okay. Now what's the probability of a red? Probability of red.
It's
5
5 out
over
of
9.
9.
5 out of 10, or
5 out of 9, isn't
It's
it?
9.
right, 5 out of 9. Which we cannot simplify. Great. What's the probability of blue now?
3 out of 9.
3 out of 9, which
Or
is
1 out of 6.
one third, right?
1/3.
Okay, great. And the probability of green?
1 out of 9.
Exactly. Great. Okay. So the probabilities change if we're not putting the balls back in the hat. So for example, if we pull the green ball out and we throw it away, what's, let's say the next thing. So we pull the ball out of our hat again. So there's 9 balls left. We pull a ball out. It's a green ball. We throw it away. How many balls are left in the hat?
8.
So we did 1 red. We did 1 green now. There's now 8 balls in the hat. So what's the probability of a red now?
5 out of 8.
Great. Okay. What's the probability of pulling a blue?
3 out of 8.
Uh-huh. And what's the probability of pulling a green?
0 out of 8.
Exactly. Adelaide got it. 0 out of 8, which is 0. Because there's no green balls left. Okay. So that's, really, really basic. But there's a few more things we need to know. Okay. So, mathematicians love to ask questions about what's the probability of doing one thing and doing some other thing, or the probability of doing one thing or some other thing. So without going too deeply into it, I'm going to give you a quick little rule here. Whenever you see the word and in probabilities, so what's the probability of doing thing A and thing B? That translates to multiplication. Multiplying probabilities. And whenever you see the word or, what's the probability of thing A happening or thing B happening? That translates into adding probabilities. Okay. I'm not going to go too deeply into it of why, but we're going to work through a couple things with our balls and hats right here so we can kind of see how this works. But universally, this is, things to just keep in your mind. And equals multiply or equals addition. Okay. So let's go back to our 10 balls. We've got 10 balls in the hat again. So, all right. So we've got 10 balls in the hat. What's the probability that I pull out a red ball or a blue ball? So with 10 balls, the probability of a red or pulling a red or a blue.
So you would add them?
That's right. So we'd say the probability of pulling a red plus the probability of pulling blue. So what's the probability of pulling a red?
6 out of 10.
6 out of 10.
Right, okay. 6 out of 10 plus probability of pulling a blue?
It's 3 out of 10.
3 out of 10. That equals, come on, fraction addition here.
9 out of 10?
Perfect, okay. And let's verify this. How many balls in the hat are red or blue?
Oh, it would
9.
be 9 because the other one's green.
Exactly. There's 10 balls and only one of them is green, right? So the other 9 are red or blue. So the probability of grabbing a red ball or a blue ball is 9 out of 10. All right. Let's change it around a little bit. What's the probability of pulling a red ball and then a blue ball? This will be a little trickier.
It would be 6 out of 10
Okay.
times.
Okay, so let's see, 6 out of 10
Times 3 out of 10.
times
So is
3 out of 10. Does that sound right?
so if you're when you have a question phrased like this, are you assuming that you're doing it in the order that the question says?
Yes.
Or does
The
that
specific,
you're like I'm gonna pull a red out first and then I'm gonna pull a blue one out?
right?
Is that assumed?
This is tricky. So I specifically said a probability of pulling a red ball and then pulling a blue ball. So in this particular case, the way I worded it, order does matter.
Right.
If I said the probability of pulling a red and pulling a blue, that's a different question.
But shouldn't they give you the same result? Or
No.
not necessarily? Okay.
And we're going to see why.
So if you say and then, wouldn't then the blue be 3 over 9 because you've already pulled one out?
Yes, yes.
Keyword.
Okay, so yes, Vanessa caught it. The probabilities are going to change because when I said and then, we no longer have 10 balls in the hat. We're going to have 9 balls in the hat. So this is actually 3 out of 9, 3 over 9, or 1/3, right? So 6 out of 10 times 1/3, that's going to equal 6 over 30, right? So that's
1 over 5.
yep. So one out of 5 times, you'll be able to pull a red and then a blue. And if we had a lot of time, we could actually go through here and sort all of these out and actually write this all up. That's not our goal today, but if you guys want to do more probability problems, I would, I can totally sit down and do more probability stuff with you. But what we're doing right now is, a little bit beyond what we'll need to do. Anyways, Lee asked, does it matter what order we're pulling out the red ball and the blue ball? And yes, it does, because what Vanessa noticed, that because the total number of balls is going to change, it's going to change the probability slightly. If we didn't care which order we pulled them out in, if we said, what's the probability of pulling out a red ball and a blue ball without replacing them? In other words, for each ball we pull out, we're not going to put it back in the hat. If we were going to put the balls back in the hat, then it would be 6 out of 10 times 3 out of 10, right? If we're replacing the balls in the hat. If we're not replacing the balls, it's a more complicated problem, because you could get the red ball first and then the blue ball, or you could get the blue ball first and then the red ball. So how would we do that? I'm gonna add a little bit to the top of the whiteboard up here, just a little space for us to write. We've solved, I'll give you guys a hint, we've solved half of the problem already. So if we're trying to figure out what's the probability we pull a red ball and a blue ball in any order.
So we've got one order.
Right.
Now we have to do the opposite.
Right. We've got the probability of a red and a blue.
So now we would do the blue first and then the red?
Right. Plus the probability of a blue and a red.
Okay, I think it's true.
It's giving a, right, this is let me make, right, this a little bit more explicit, or the probability of a blue and a red. So the probability of a red and a blue, we already solved that one, right? That was 6 over 10 times 3 over 9, right? Plus, so what's going to be blue and red? The probability of blue and red.
So it's 3 over 10 and then 6 over 9?
9. Yeah, you cross multiply.
Yep, there we go. So we know the first side is, simplifies down to 1/5, right? So we'll keep that there. So on this side, we're going to get, 3 times 6 is 6, 12, 18. 18 over 90, which, who wants to simplify that? 9 goes into both sides, right?
2, and then 10, and so 1 over 5.
Okay.
The same thing.
Turns out it's the same thing here. And so we've got 1/5 plus 1/5. So it's 2/5. 2 out of every 5 times, you're going to get a red and a blue. Okay. So there's your quick probability recap. So the things to keep in mind here are, probability equals the number of positive.
That's just coincidence that it's 1/5 again?
In this case, yes.
In this case, okay.
Right.
It's not always going to be like that.
Right. Another positive outcomes divided by number of total outcomes. So in general, when you're solving probability problems, this is what you're looking for. This is what your answer is going to be. The number of positive outcomes, the thing you're interested in, divided by the total number of outcomes. And then the other two kind of gotchas are, whenever you see and, it means you're multiplying those probabilities together. And when you see or, you're adding those probabilities together. There's one last thing that's kind of just a side note that I'll throw at you right here. Sometimes when you're solving probabilities, if it seems like it's really tricky to find the probability of the thing you're looking for, you can also think about it as the probability of this thing happening is 100% minus the probability of anything else happening. So what's the probability that I don't pull a green ball out of the hat?
That you don't pull a green ball is 9 out of 10.
That's right. And so you can actually
take the total number and subtract it by how many it is?
Right. So if there's if the probability of pulling something pulling not a green ball out of the hat is 9 out of 10, 10 out of 10 minus 9 out of 10 equals 1 out of 10, right? So the probability of pulling a green ball out of the hat is 1 minus the probability of pulling anything else.
So there's really 3 scenarios. You said there's and or, but then there's the third scenario is and then.
Oh, you mean for a specific order?
Yeah, like you were saying, there's a rule. When it's and, it means multiplication, or it means probability. But there's a difference between what's the probability of this and this happening implies that there's also it's this thing happening or this other thing. It's like it kind of becomes both as opposed to and then.
Well, the reason I said and then is because I wanted to do the simpler the simpler problem, right?
But when you have an and, that's what I'm saying, and not an and then, you're not only multiplying each version of it, then you're adding them together afterwards. That's what this thing on the top is, the probability of red and blue, or the probability of blue and red is 2 ands combined with an or,
Right. Because in this case, there's 2 different ways to pull a red and a blue. Then it changes things. If I asked you what's the probability of pulling a red ball and another red ball without replacement?
So in that case, there's only.
In that case, the
probability is going to be the same whether it's the red ball with this red ball versus that red ball. It doesn't matter.
Right. So I think it'd be. We don't have to do all the numbers, but what would it be? It would be 6 out of 10 times
5 out of 9.
Yes.
Okay.
So don't worry about doing the multiplication. It's like
6.
It's like 30 out of 90 or something like that. So
Whatever.
1/3, something like that. But but in that case, the order doesn't matter because they're both red.
Right.
What's the probability of pulling a green ball and then pulling another green ball without replacement?
It would be 1 out of 10 and then 0.
Right. Adelaide got it. It's 0 because there's only 1 green ball.
Got it.
Okay. All right. Now does anyone have any questions about basic probability? What I just gave you, this is enough to cover you for basically any basic probability question you're ever asked in your life.
It's worth gold.
Okay, great. In that case, let's actually go to the real problem that on the test then. I'm going to
What
go
is
ahead
the
and
probability after the GRE is that we will be asked probability questions?
Never.
for
In
me,
calculus.
pretty
Yeah,
often.
for you.
For me,
you,
pretty
yeah.
often.
Got it.
Yeah.
Like, read it on your, put it on your.
So one time we were with Scotty's friends, his work at Tubit, and he was we were playing board games, and just the expression, what are the chances?
Yeah.
Well, I rolled the dice in front of these engineer guys that were playing the board game. I rolled the dice and I got a bad play, and I just said as an expression, what are the chances that I'm gonna get that number? And one of them turns around in this relief that I just asked this question and says 1 out of 6, and I was like,
Like, duh.
Like,
We
seriously?
should know this, Annalise.
just looking at him like,
Was there 6 of you total? Was there 6 of you total? Is that why?
no, because of the
Because of the
dice.
It was a
dice.
six-sided
dice.
It's
die.
a
What did I
six-sided dice.
That's horrible.
But I was just, I just stayed like, man, talk about lack of social cues here. And then Scotty turns around and looks at me and he's like, what do you expect? These people are all like math people. Like, you can't ask what are the chances because they're probably going to know. And I'm like,
And they'll explain it to you all around.
I know. But I'm over here like, they're all autistic. That's what I think.
You think all
Be
people are
literal.
autistic?
Oh,
I do.
no.
I do. think
You're always
everyone-
like looking, yeah.
I do always think that everyone's autistic.
You're always scanning everyone for that.
Okay, and also no joke. Yesterday, when I had my all-day interview at was one gaming company, they asked me a probability question, and it turned out to be a trick question, and I realized it was a trick question and that it was unsolvable. So I'm glad that I was able to do that.
Wow.
That's good.
And it did have to deal with pretty standard traditional probability stuff. Like it had to deal with coin flips and dice rolls and stuff. And it's like that was an interview question for me.
Damn. Oh my god. And then you're here with us after that interview. Oh my goodness. Keep
Okay.
it going, God.
Right. So I'm gonna leave up a little bit here, but I'm gonna erase most of this. So yeah, we're gonna get rid of the balls and the hats and all this stuff over here. I'm gonna leave up this, sort of our little cheat sheet stuff, because this question does refer to some of these things. Okay. All right. So the question that Vanessa read for us, what seems like years ago now. So there's 100 students who transferred from other institutions. Of these, 34 transferred from two-year college, 24 transferred from private four-year college or institutions, and the rest transferred from public 4 years. If 2 different students are to be selected at random from the 100 students, what is the probability that both students transferred from 2-year colleges? This is just the balls in a hat problem. That's all this is, but rewritten to have to be college students. Otherwise, it's the balls in a hat.
Okay. I think I have an idea of how to write it.
Okay, I'll go ahead and mute my mic so you can talk for a minute then.
Would this then start with 34 over 100 times 25 over 66 times 41 over 25?
But they're both muted.
Yeah, you're both on mute.
We
We
have a
can't
total
hear
of,
you.
sorry, we have a total of 100 students.
Yeah.
Okay. Right, so there's 100 transfer students.
Yes. And then you would have 34 that are from a 2-year community college. So I would just put, so I just wrote down 34 and then 2-year.
Okay, 34 from 2 years.
Yeah. And then you have 25 private. So I put P4 for private,
Okay.
4-year.
Private 4-year.
And then you have 25 T. I'm sorry, 25.
I think
Sorry.
it's 41.
It's 41. 41 for P 4-year. I'm sorry. Yeah, it's public. So I'm glad
Public
you
4
wrote
years.
private. So public. And so if I base it upon what you did earlier, we need to find all the different probabilities in order to know what the chances would be.
Yeah, essentially.
Wait, you're both unmuted.
Right,
Do we
right.
need to know
So-
all of them?
Well, basically, we've got 100 balls in the hat. 34 are red balls, 25 are blue balls, and 41 are green balls, right? You know,
Thank
This
you.
is
Thank you
just-
for making that connection, Scotty.
this is just the balls in the hat problem. Okay, but yeah, Adel, you're definitely on the right track for solving this. Do you want to keep going? Go ahead.
So then you would have to find out first what the probabilities are for like finding what the 2-year is, what the 25 and the 41 is, which you can go ahead and take that away because I haven't gotten that far. I just
Well-
kind of like just,
Well, just read the question.
okay. If it says if 2 different students are to be selected at random from the 100 students, what is the probability that both students selected will be students who transferred from 2-year community colleges? Okay, so they want to know what the probabilities are for 2 terms for only the 2 community colleges. Okay, so then that would be grabbing the number for 2 transfer 2 years. So transfer 2 year is a 34, so it would be 34.
Right. So let me write this out like this first. So what they want is
You need to unmute yourself again.
right. So let's write this out. What they want first. So what they're asking for, they're asking for if 2 different students are selected at random from the 100 total. What is the probability that both the students selected are from 2-year colleges, right? So they're saying, let me write it up here. So they're asking for the probability of something and then something and then the probability of another thing, right? What are they asking for? It's the probability of
Which students from the transfer 2-year community college were transferred. So you're going to have to do the 34 over 100.
well, it's the 2-year, right?
Yes,
Probability of which ball do they want to pull out of the hat?
the first one, 34 2-year.
Well, the 2-year. Okay. Probability of the 2-year.
Yes, and also a probability of the 2-year. They want 2 students from the 2-year community college.
Okay. And they said and or?
They said
They didn't
And-
say either, I think.
they said and.
2 students.
Oh
are
no,
selected
I'm sorry.
At random.
It doesn't say and. but
Doesn't
it
say
implies
and or.
Yeah,
no,
see?
It says
No.
if 2 different students to be selected at random.
What's the word that they use? They use the word both,
So,
right?
Both.
So
yeah,
that's
both.
and.
So they didn't say either. They
So
said
it's and.
both.
Okay.
Right. So is that and or?
And
And
There we go. Okay. And 2-year, right? Okay. So does everyone see how we got to what did everyone see how we translated that awful paragraph with lots of big numbers in it into the question they actually wanted?
Yes.
Okay.
Keywords.
Right. Okay, Adelaide, go ahead now. I was trying to keep you from jumping too far ahead, but now go ahead and solve it. Yes, you're talking.
Okay. Well, now you're gonna have the 34 over 100,
Okay.
and then you are going to multiply that by 34 over whatever the amount is of minus 34, which is 66. So it's 34 over 66, isn't it? Because you already took 34 out.
How many
Didn't you
students
just
did you
take
take
one?
out?
Just one, no?
Yeah, how many students are?
Okay, so it would be 33 then? 33 over 100? No, 33 over 99.
99.
99.
There we
People
go.
took that
Okay, you got it. All right. And let's make this a little simpler.
You need to unmute yourself again.
We can still hear them.
Wait, I'll listen.
Okay,
Either way.
and great. So we're doing great so far. Let's simplify this a little bit. So 34 over 100 times, what's 33 over 99?
1/3.
1/3.
Perfect. Okay, great. And we can simplify this one too, right? 34 over 100. So I'll save you guys a little bit of time. 2 goes into both of these. So what's 34 divided by 2? 17, right? Okay. So this is actually 17 over 50 times 1 over 3. Okay, Adelaide, I'm going to give you your moment here. What's the answer?
He's muted.
I'm muted. I'm not anymore, but I don't know. What do you mean? Where's my moment is being ruined by
You
a
just multiply
fraction?
17.
Multiply across.
17 times.
Also,
yeah,
17 over
I know.
17
It's
and
a lot.
150.
Yay, Adelaide!
Thank you, guys. That looks rough. I'm building a koala. That's all.
All right. I am so proud of you, Adelaide.
Thank you.
You did.
No, seriously. You
I hate
solved
fractions.
it. You solved it.
hate fractions.
That was good. Wow.
Okay, so
Oh,
yes,
my
that
goodness.
is the answer. That is the
Mhm.
simplified answer. And that's as far as you can go. That is the correct answer. It's 17 out of 150. It looks a little weird, but yes, that's the right answer. But the whole reason I went through that whole balls in a hat thing is because when you get a probability question on the GRE, it's going to be one of the following kinds of problems. It's going to be pulling balls out of hats. It's going to be flipping coins. It's going to be rolling a 6-sided dice. You know, those are the kind of problems you're going to get. This problem is just pulling balls out of a hat. It's just some of these balls went to 2-year colleges and some went to 4-year private universities. You know, these are very educated balls.
My very educated.
Yes.
Uh,
Oh, my.
Okay. Does this make sense to everyone, though?
Yes. Thank you so
Yes.
much for that.
Okay. Great. Fantastic. It's 4:40. Do you guys feel like going all the way to 5 o'clock?
I'm
Or,
good, guys.
are you
I'm
guys
hungry.
are you guys getting brain drained?
I'm just hungry.
I say one more question, you guys.
Okay, Adelaide's asking for one more.
this one's actually a 3-part question. The
Yeah,
next one.
this
Then.
is 3 parts.
Ooh. Let's
Because it's
see.
using the chart.
All right, these last ones, they're all like looking at the data kind of things.
This one wasn't too bad though.
Think we can get through
I
all
think.
three? Yeah, I remember hating these problems.
I hated
but-
these.
They're bad.
Okay, but I have very little actually written down for them. It's like they're very simple if you know how to approach them, but it's I hate doing these. I hate doing like math and accounting kind of problems.
Yeah.
As Adeline is well aware of today. We were like looking at like tax stuff, and I was like,
Oh no.
she was like looking at me like frustrated, like, you need to know this stuff, and I'm just looking at her with like sad puppy dog eyes. Like, do I really?
You're like, I don't know everything.
Can I stick to balls
But
and
you're the
hats
math
and
king.
You just hire an accountant.
yeah.
It's an
Yeah, there you
essential
go.
service.
To me, it was like, you know, so many complicated things. Should be like sticks and
Sometimes-
stones.
That's the real
Sometimes
stuff.
the easiest things are the hardest, though,
Yep.
because then you overthink everything.
Yeah, because he's also used to all the hard stuff. So when it's easy, he's like, it can't be
It's
this
like,
easy.
well, yeah.
Okay,
And
let's
with
see if we
Pepsi.
can. Let's see how far we can get. Okay. If we don't finish, we don't finish. But let's see if we can get through. Okay. So data interpretation sets. So yeah. Apparently, this is a thing that's on the GRE now. Is they've removed calculus and they've brought in more of statistics and like being able to read graphs and data and things.
That's probably better. Calculus is just nonsense.
Yeah, I was gonna say, I think that's better.
This is actually useful.
Well, there's a
Rocket
lot of
scientists.
it's calculus is more
Imaginary,
required.
no?
Well, calculus is more for like engineering focused, whereas like reading data data and sets and statistics is much more in demand for people going to pretty much anything else. If you're not going to something that's hardcore mathematics and engineering, then you're probably dealing with statistics. So that I think that's why part of the changes to the GRE is because this is a more generalized skill set that covers more areas of non-engineering. So let's take a look at this. So we've got these businesses that jumped into the whole business thing early, and we were able to reserve business names with single letters. Someone managed to copyright the letter G for their business name. Okay, so first question. If the value of the inventory at business K was 30,000 for April, what was the value of the inventory at business K for June? So who wants to jump in with this one? And also, if you're using a PDF viewer, if you use like a 2-page view, then you can see both pages at the same time.
I can tackle this one.
All right.
If
Go for it.
okay, so
I hate these problems anyway. Someone else solve it.
Great. All right, so let me do an annotation. I'm only going to put the part of the chart that is relevant to K, because business K is the only one we care about right now.
Mhm.
K, K business, 5% change April to May, and then negative 5% from May to June. Let me see if I can expand this. Okay, you guys can see that?
Yes.
Okay, so if you're starting with a value of 30,000, so that's where we're starting, right? What is the value of the inventory at business K for June? So basically what we need to do is figure out how much their value changed from April all the way to June. But, this is a linear time problem. So it's not like this number can just go into the future. Their value changed at the end of May. You have a new value to start with based on the fluctuations. So we first have to figure out, before we figure out what our number is at the end of June, we need to figure out the first section. So 30,000, if it's a 5% increase, basically what we're starting, you know, if we consider our starting value as 100%, that's our starting value. So a 5% increase really takes our starting value and makes it 105%. And then when you're talking about a negative 5%, you're actually, another way to phrase that is if you have a negative 5% decrease, your starting value, you have 95% of your starting value. Is everyone with me so far?
Yes.
Yes, okay. So it's really just a matter of multiplying this in that sequence. So it's 30,000, I won't use X, times 105%, and then times 95%, and that is going to give us our final value after June is over. And so the way to do this easily on a calculator is 30,000 times, so I basically just convert these percentage values to be decimals. So 1.05 is equivalent to 105, and then 0.95 is equivalent to 95%. So if you do that in that order of operations, you, let me just check my math here, make sure I didn't make something up. So 30,000 times 1.05 times 0.95 is 29,925, which is choice B. That's it. Thank you for clapping, Scotty. Appreciate it. That's pretty much it. I mean, just the hardest thing is just being comfortable with changing percents to decimals, because it makes it really easy to multiply on the calculator like that. So.
Okay.
Okay, great. Yeah, that's exactly how to tackle that problem. Yeah. So that's the first one down. Did anyone have any questions about that? Does that make sense to everybody? Fantastic. Okay. Who managed to get number 2 right?
I also got that right, but I don't remember as clearly as
Okay.
how I did it. I have an equation here, but it's like, I'm like, how did I get that? Business and what percent of volume?
Okay.
Business M.
Okay. At business M, the value of the inventory for May was what percent of the value of the inventory for June? That's a really terribly worded question. But it's the kind of thing that they're going to throw at you at the GRE, because they're just going to try and, confuse you and scare you with the way questions are worded.
Oh, okay. I remember how I did this.
Okay.
Yeah. Sort of. Let's see, one. Okay. Yeah. I remember now.
Mm-hmm.
Unless anyone else wants to do it.
Can I ask a question?
Sure.
I got confused in this because in the chart it says from April to May and then from May to June.
Mm-hmm.
So I wasn't sure, like, and then the question asked for inventory from May to June. Was it just talking about the second column then? Because
Well,
both
the
Mays
third
overlap.
column, right?
Yeah, the third. Just that one?
Right.
Okay.
Yeah. So yeah, I just ignored the whole first column.
Okay.
Or sorry, the second column, the percent change from April to May, because we're starting
At May.
with May, and we're moving into June. So whatever
Okay.
we start with then doesn't matter what happened in April.
Okay.
So the business and the value of the inventory for May was what percent of the value of the inventory for June. So we want to know the relationship of June when we from what we started with in May. So we have a similar thing here. So let me do the chart. So percent change, I'll change the color since we're on a new problem. Percent change from May to June is a positive 12%. I won't put the plus sign, but percent change from, oh, what happened to the 12? That was weird. 12%. So I sort of thought about this the same way that I did before, is how do I get a percentage to a decimal that I can multiply? So June, the value of when we get to the end of June is the starting value of May times an additional 12%. So it's basically 112% of what our starting value was. And so that equals May value times 1.12. Oh, it didn't stretch it out to one thing. Are you able to, how do I change that text box again?
If you use the select tool.
So there is no select tool on my
Okay,
screen.
I'm going to take control.
I
We
can't
can
see it either.
stretch the box a little bit.
Yeah.
Thank you.
There
There you go. Perfect. That's what I wanted.
There you go. Okay,
Okay.
You're back.
So now I'll draw it in a similar way. So I'm just going to use J for June and M for May. And so I have J equals May times, that's supposed to be a parentheses, undo. May times 1.12. This is really hard to do without a stylus. Okay, so what I want to figure out, and there is a decimal in there, that's 1.12, so please ignore that. And so again, I'm starting with J as being 100% of my value. It doesn't matter what my value is. So J is really like 100, and May would, May would be 100. When I add 1.1, multiply 1.12, I get June. So basically I can treat this like a normal equation, and I can divide the 1.12 to cancel these. And then I have June divided by 1.12. Okay. And so if I treat June as my new starting value, and I don't remember why this works, I guess, but I basically subbed in 100 for June. June is like, you know, the value that I want to know what's, if I want to, sorry, I'm losing track of how to explain this, but I did 100 divided by 1.12, and I got 89.3, and that's the answer. And I put a question mark next to it because I was like, I'm not sure if that's right, but it ended up being the answer. So maybe someone can explain better why that's, you know, the thing. But basically, I'm trying to figure out the relationship of, yeah, June is May's value. I just don't remember why it worked to substitute 100 for June.
Okay, I'll go ahead
I took
and
a stab in the dark.
Yeah, you're definitely on the right track there. That, I mean, you did get the correct answer, and you got it the right way. But basically, the way that I was going to take over a little bit there. So essentially, what I did, I solved it by just thinking about it as a ratio, right? It's saying what was the percent of the value of the inventory for June? What the value of the inventory for May was what percent of the value of the inventory for June. So I thought of it as a ratio. So it's like, okay, well, if in May I have 100%, you know, of the inventory, whereas in June I have 112, right?
112, yeah.
And then I just, you know, solve the ratio for that, and that gets you, you know,
Oh, that gets you the
rounded.
same answer.
Yeah, 89.3%.
Got it. That was a lot faster.
That makes sense.
It's, I mean, you solved it pretty much the same way.
Yeah.
We just thought about the logic a little differently. I mean,
Yeah.
in either case, it comes down to basically one division operation here.
Yeah.
You know, so yeah, that's 2. We got 4 minutes. You think we can get through 3? I'll take control for now, so we can kind of get through 3 kind of quickly and kind of finish it up. But great job, Lee.
Hey, Lee.
I know.
Okay. So 3. For which of the 6 businesses shown was the percent change in the value of the inventory from April to June greatest? So real quick, I'm just gonna take control just for this, for the beginning here. Just to kind of help you guys see a little bit of a shortcut here, that you know, to do this problem, you would have to, you know, calculate the difference of all 5 of the companies, right? Except that, excuse me, all 6 of the companies, except that there's one major shortcut that you can take to get rid of a whole bunch of the options. Right? And what is that? It's a pretty obvious one when you look at the 3rd column of the data.
There's some negative values that negate.
Right. There's some negative values, and they just, when you add those negatives together, it just blows those ones out of the water. It's like, oh, well, you know, it went up 5%, but then down 5%. So that's, you know, that's not going to be, there's no way that could be greater than the, you know, the change could be, percentage change can be greater than the one that went up by, you know, 2% and then 12%, right? It's like, you don't even have to do the math for that. You can just look at it and say, I know that's going to be less. So if we just disregard those ones that have the terrible negative values, you know, how do we solve the other ones then?
By amount of quantity, like you have an A, a 12, and a 0.
So K, R, and Z. We're just going to throw these guys right out.
Z wasn't even a choice. So.
Yeah, Z isn't even on the answer sheet, so you don't even have to worry about that one, right? It's an impossible answer. If it's not even on the answer sheet, just don't even worry about it, right? They're like, we know that one's too obviously bad. They didn't even bother making it a valid answer. In fact, it's like the only thing Z is doing is just taking up space on this sheet. None of the answers involve Z in any way in this data set for any of the questions. So yeah. And so Adelaide, you said you had a thought of how to solve this. What did you say?
Well, you have, I think, just the order of numbers. I mean, you have
8 and then 12 and 0. So the percentage change is, you know,
right, but we want to track the percentage change all the way from April to June, not just May to June.
so you add them, right?
not add. What did we do for that first question?
You do the whole 100. So in G's case, it would be 6 plus 100, so it's 106. And then
right, okay.
And then May to June, it would be 108%.
Right. 106 times 108.
Yes.
Right. So 106% times 108%. Right.
And if you simplify them, like Lee
yeah.
did.
So this is for G, right?
Yes.
So 1.06 times 1.08. And I've already got that written down here, so I'll just write that out. That's 1.1448. So do we need to find K? No, we don't.
No.
So how about N?
Yeah.
All right. So what would N be?
102 times
102%?
112.
Times 112%?
Yes.
Great. Okay. So
And you do them all.
1.02 times 1.12, right?
Yes.
That's 1.1421. Do we need to find company R?
No.
No.
Yeah. Okay, what about company V?
No. Well,
We
would be
do, but
114.
it's easy. Yeah.
It is easy, right? Okay, so what is company V?
It would be, actually, it would be Sear. I don't know.
Well, it's
Okay,
a 0% change.
right. So what does 0% change equal then?
It's 1.
Right. So 1.14 times 1 equals 1.14. And that's really all we have to look at. All three of the other corporations have so large of a negative change to their percentages, we don't even need to bother worrying about them. And then Z isn't even on the list. So from there, so now we can see which company had the largest percentage change.
G.
Yep, there we go. So
Actually, the largest percentage change. It's actually, you can't discount the negative because it could be a negative change. So it could have been that could have been a tricky part of the question because it doesn't
you know what,
say
you're
which
right.
is the largest increase. It says the largest percentage change.
Okay, so you're right. That actually could be I didn't think about it that way, but you're right. We could, if it was the way the question is worded, it doesn't say the largest increase. It says the largest change. So you're right. So let's actually just write that out real quick. I'm gonna undo this. So let's see. So what would K be if we did K?
105 times 95.
105% times, all right, 0, or so 95. So let's just go ahead and figure it out. Equals 1.05 times 0.95. Anyone got a calculator that can run the numbers real quick?
0.9975.
9975. Okay. Well, it's not a negative change, right?
It's still not the largest.
Right.
And you can kind of assume that it's going to be lower, because if it went up and then down about the same amount, the same percentage, if you were like running short on time, you could probably discount that.
So to get let's actually look at this. To get a negative change, what would those percentages have to be in order for us to get an actual negative change? It would have to be over, it'd have to be minus 100 or greater, right? They'd have to lose over 100%.
Right. Yeah. So it is a negative change, because if their value is 1.0, having an ending value of 0.9975 is a negative change. Because this is the, isn't it?
But it's just asking for a percentage change.
Right.
So in other words, going from 100% of their inventory, they went down to 99% of their inventory, right? A little over 99%. So it is a negative, it is a change downwards, but it's still not.
Right. It's not the largest percentage. Yeah.
Okay. And we could do R as well, but it's, it's not even worth it, I think. It's pretty obvious from looking at it that it's not going to be much different. All right. So yeah, that's I think we have just 3 left, but we'll do those maybe at the beginning of our next review and then move on to other stuff. So here's what I think your homework should be. Whatever you had the most trouble with on this practice test, whether it be the probability, whether it be statistics, whether it be graphing, or function composition, or geometry,
Or all of them.
Or all of the above.
All of the above.
Whatever you liked the least, try and find some practice problems online of that. Do them, try and understand them, and if you can't, bring it on our next meeting and we'll go over it together. So we'll finish up the practice test next time, and then I'll try and everyone bring a problem that is difficult for you to understand, and we'll do it together.
What about the book? Are we gonna go back to it?
Yeah, I think so. We'll go back to the book, but I don't want to. Adelaide asked if we'll go back to the practice GRE book, and absolutely we will. But I don't want these sessions to just be me going up to the whiteboard and dictating to you guys the whole time. I want you guys to go out and do a little bit on your own too, and we'll try and scan a few pages for you guys to work on as well. But in the case that we don't, please remember that this is the only way you get better at these problems is by doing a lot of them. So, spend an hour over the weekend and try and find, some math problems in that particular, in a thing that you're not very good at, and try and learn it and understand it. And then come in and if you don't understand it, bring it to us and we'll try and work through it together. If you wound up understanding it better, then you can present it and work through it with us, and we'll all cheer for you and clap, and we'll all love you because you'll be teaching us something.
That'd be a good
Thank
one.
you.
I like it. Okay.
Okay, great job, everyone. These are
Thank you so much for your guys' time.
Yeah, no worries. These are tricky problems. Don't get discouraged if they were all hard, because that's the point. The more we do these, the more and more tricks you'll pick up, and the easier they'll get.
Okay.
All right, I'm gonna go ahead and kill the recording, and we're off.
Bye. Thank you.
Bye. Thank you.
Bye, guys. Thank you. Have a good weekend.
You too.
Bye.
Take care.
Mhm.
Bye. Thank you for your time.
Bye.